You know the tech you use every single day? The smartphone in your pocket, the electric vehicle on the street, even those advanced stealth fighter jets we see in the news. Well, the invisible forces powering all of them and driving some massive geopolitical tensions are actually buried deep underground. We are talking about rare earth elements. These are the absolutely crucial, highly sought-after minerals that make modern life possible. In this explainer, we're diving into a massive global shift. It's literally a frantic scramble for resources that's fundamentally rewiring international supply chains and reshaping global power dynamics right before our eyes. Let's get into it. To kick things off, we really have to ask ourselves a critical question. What actually happens when one country controls the future of technology? Because rare earth elements are the absolute necessity for modern defense and green tech, this isn't just a hypothetical. As the source material shows us, the global supply chain for these materials is precariously concentrated. To understand why the United States, India, and the G7 are suddenly scrambling to invest billions of dollars all over the globe, we have to tackle this exact question. It's no longer just an economic issue, right? It's a matter of national security and, honestly, technological survival. Here is our roadmap for understanding this high-stakes global shift. We'll start with the rare earth choke point, then look at America's billion-dollar countermove, followed by India's push for independence. After that, we'll examine the hidden environmental costs, and finally, we'll wrap up with the long road ahead. Okay, Section 1, the rare earth choke point. Let's see how this geopolitical bottleneck actually developed. So China effectively holds a monopoly over the elements that are vital for everything from your EV to military defense systems. While they mine about 60% of the world's rare earths, their processing capacity is what's truly staggering. They control nearly 90%. That creates a massive global bottleneck. What that means in practice is that even if you dig these critical minerals out of the ground in places like Australia, Canada, or the US, they almost always have to take this costly, complex detour right through China just to be refined into usable high-grade components. And the severe vulnerability of our global supply chains became glaringly obvious during the rapid escalations we saw throughout 2025. Back in April, China introduced sweeping export restrictions specifically targeting heavy rare earths and permanent magnets. Then, by October, this expanded into a full-blown tech embargo and a strict foreign direct product rule. That meant even foreign-made products containing just trace amounts of Chinese-sourced materials required explicit approval from Beijing. Wow. Now, while the late 2025 trade truce between Trump and Xi put a temporary pause on all this, the underlying fragility of the market, that remains entirely unresolved. Listen, replacing this supply chain isn't just about digging more holes in the ground. It's really about mastering that incredibly complex and incredibly expensive middle step, chemical processing and separation. You know, you can mine raw ore all day long, and you can build high-tech factories to manufacture magnets, but separating these chemically identical elements to high purity levels, that's an immense scientific challenge. Right now, the rest of the world is desperately trying to catch up to decades of specialized expertise that's been heavily concentrated in just one region. When we look for alternative ways to break this monopoly, it's essentially a game of really difficult trade-offs. On one side, you have methods like chromatography. This is highly precise, sure, but it's currently unscalable for massive commercial volumes and just incredibly expensive to run. On the flip side, you've got high-acid leaching. Now, this scales beautifully for low-grade ores, but it's highly toxic and requires massive amounts of chemical reagents. So right now, there's just no magic bullet. We simply lack a perfect, easy technological fix to bypass this processing choke point cleanly. Let's move on to Section 2, America's billion-dollar countermove. To counter this strategic vulnerability, the United States government is deploying a massive flow of capital. We're talking well over $7.3 billion across various departments, all to build a supply chain completely free from Chinese reliance. The Department of Defense is heavily backing domestic facilities, pouring hundreds of millions into places like MP Materials in the US, while also striking equity deals as far away as Saudi Arabia. Concurrently, the Export-Import Bank is issuing billions of dollars in letters of intent for projects in Australia, Angola, and Canada. This is literally a comprehensive whole-of-government mobilization to reshape the global market from the ground up. 60%. That is the ambitious, aggressive target set by the G7 nations. By the year 2030, the world's advanced economies aim to reduce the reliance on any single supplier for rare earths and permanent magnets to below that 60% threshold. And get this, they aren't stopping there. They have an ultimate goal to push that number down to 50% as quickly as possible. It's a unified global signal that Western economies are moving urgently to secure their own technological and industrial futures. Which brings us to Section 3, India's push for independence. Now, how does another major global player factor into this? Well, India is leaning heavily on its biggest corporate titans to build domestic rare earth processing, basically from the ground up. You see, while India officially holds the world's third largest rare earth reserves, they completely lack the commercial-scale processing facilities to actually use them. So now they're bringing in heavyweights like Reliance, Vedanta, and Adani to tap into an estimated 211 million tons of beach sand minerals located in Andhra Pradesh. It's a massive, highly competitive effort aimed at closing that processing gap at record speed. India is really executing a multi-pronged scramble to secure materials from two distinct fronts. Domestically, the government is pumping in a 7,300 crore federal incentive scheme to boost local magnet manufacturing, alongside 1,500 crore critical minerals mission focused on recycling. But internationally, they're casting a massive, highly strategic net. State-backed miner IRL is deep in negotiations to source rare earth samples from Russia's Tom Tor deposit, while simultaneously scouting fresh mining opportunities across Argentina, Australia, and Malawi. They are absolutely leaving no stone unturned here to feed their future magnet production. All right, let's look at Section 4, the hidden environmental costs. So, while the financial investments we've talked about are massive, the crucial point is that this global critical minerals boom comes with some severe caveats. A recent comprehensive report reveals a stark disconnect between what massive mining companies promise on paper and what actually happens on the ground across Asia. We're looking at roughly 140 mining assets projected to face severe water stress by 2055. There are persistent vulnerabilities regarding modern slavery deeply embedded within the supply chain. And the long-term planning? It's pretty abysmal. Only 2 out of 14 assessed operators are actually prepared with proper mine closure planning. The rush for green tech is, unfortunately, leaving a significant footprint of exploitation and neglect. It's a sobering reality check. The much-celebrated green energy transition heavily relies on highly disruptive extraction methods. Over 57% of the biodiversity impact from this industry comes simply from land use change. That literally means clearing out entire natural ecosystems to dig massive open-pit mines. Another 32% comes directly from the associated pollution. So our push for clean energy vehicles and wind turbines actually requires a supply chain that fundamentally tears up the earth just to get started. Furthermore, data from the UN highlights a massive structural inequality in how this global transition is actually funded. Developing nations that are desperately trying to build clean tech infrastructure and secure resources are bottlenecked by borrowing costs that are more than double those of advanced economies. While advanced nations borrow at an average rate of about 2.2%, developing nations face a staggering 5.5% rate. To put that into perspective, this single discrepancy drains roughly $500 billion annually from developing nations, funds that are desperately needed for healthcare, education, and their own green tech deployments. Okay, let's dive into our final section, Section 5, the long road ahead. What does the future of this geopolitical shift actually look like? The major complication here is that rare earths are dual-use items. Heavy rare earths are needed just as much for the commercial motor in your electric vehicle as they are for advanced military radar systems and precision munitions. Because of these overlapping applications, blurring the lines between commercial use and highly classified military use, securing export approvals remains incredibly difficult and highly politicized. And because of this dynamic, strict export licensing regimes will likely cause supply bottlenecks to fully persist well throughout 2026. An analysis from the Center for Strategic and International Studies points out a hard truth. All these billions of dollars in policy announcements don't really mean a thing until we see actual, sustained physical output. Mining and processing facilities take years, sometimes even decades, to come fully online. The ultimate test for the United States, India, and their allies is whether they can attract enough private investment to ensure these new, diversified, and highly complex supply chains can actually become commercially viable in the long run. As we watch this great rare earth reset unfold globally, this is the ultimate question we must ask ourselves about the true cost of our modern technological resilience. Are we truly breaking a monopoly, or are we simply replacing it with a more fragmented, far more expensive, and environmentally taxing global puzzle? We are absolutely shifting away from a single choke point, but the new map is incredibly complex and fraught with steep economic hurdles. Definitely keep an eye on how these massive investments play out on the ground over the next few years. Thanks for joining me for this explainer, and keep questioning the systems that power our world.